In the name of God. Praise be to God, and upon the messenger of God, Muhammad, and upon his family. Now then, we begin with you the Power System Protection course. From the name Power System Protection, we want to establish protection for the power system. To understand the power system, we need to know what it is. The power system is the electrical power system that usually starts from the generator, which is typically a synchronous generator found in power plants. Using a synchronous generator gives me fixed voltage and fixed frequency because the generator produces voltage ranging from 6.6 to 30 kV. We transfer the voltage from the generator to a step-up transformer, which converts, for example, if the generator gives me 15 kV, it will convert it from 15 kV to 132 kV, or possibly from 15 kV to 400 kV, or could be from good. The transformer serves multiple purposes. Using a step-up transformer increases voltage, while reducing current, which decreases power losses calculated as I2R. This is the first goal. The second goal is efficient voltage transmission over long distances. Without a transformer, voltage drops significantly. Another goal is to maintain voltage levels despite losses, using a tap changer to adjust. The generator produces voltage, the transformer steps it up, and then it's transferred to the next transformer. Power losses are I2R. Raising voltage decreases current, thus reducing power losses, which is a key transformer goal. Another goal is to transmit voltage over long distances without significant drop. Transformers raise voltage to counteract this drop, using tap changes to adjust as needed. The generator produces voltage, and the step-up transformer increases it for transmission. Transmission is either within or outside the city, with specific specifications and protection features. The transformer's goal is to increase voltage. Voltage lost is compensated by the tap changer to restore voltage. The generator generates, and transformer increases it. Transmission lines are either within or outside the city. If transmitting within and then outside, it can be retransmitted. Entering another city allows retransmission. They have specs and protection features differing from underground cables. The transmission line here is divided into two parts. It can either be within the city or outside the city. If I enter another city, I can transfer it again. Now, they have specifications and characteristics that we will talk about, and they have specific protection features that differ somewhat from the protection of underground cables. After reaching the other station, the busbar will receive the power and then feed the transformer, which is a step-down transformer. This transformer steps down the voltage from 132 kV to, for example, 13.8 kV or 11 kV. This power transformer, after it generates to 13.8 kV, it differs somewhat from the protection of underground cables. After reaching the other station, the busbar receives power and feeds a step-down transformer, reducing voltage from 132 kV to 13.8 kV or 11 kV. Take 13.8 kV to a distribution transformer, converting it to 0.4 kV. Heavy loads like cement or steel factories can't use three-phase 400V. This dimension only generates, let's assume I will take 13.8 kV to another transformer of the distribution transformer type, which will convert again from 13.8 to 0.4 kV, for example. Now, reducing the voltage depends on the type of load to be fed. If the load is of the heavy load type, or for example, a cement factory or an iron factory, then I cannot give an iron factory three-phase 400V, for example. Phase 4400 volts, for example. So I give him, for example, 30.8 kilowatt or 6.6, or depending on the load he has. So I reduce the voltage according to the load he has. And of course, the load in an iron factory or cement factory is not the load in a house, which consists of lights, a stove, a refrigerator, and a television. Depending on the load, I provide the power or voltage that it needs. Now we notice again that the power system consists of generation, transmission, and distribution. Instead of saying generation, transmission, distribution repeatedly, I can refer to it as one term, power system. Now let's return to power system protection, which means protecting generation, transmission, and distribution. Instead of saying protection for generation, transmission, and distribution, I say power system protection. In this course, we will explain the rules of protection in general and gradually delve deeper to connect the job market with the theoretical side of protection. So stay with us. Together, we can inspire the nation's revival. So, it's the protection of generation, transmission, and distribution. Instead of saying protection for generation, transmission, and distribution, I say power system protection. In this course, we will explain the rules of protection in general and gradually delve deeper to connect the job market with the theoretical side of protection. So, stay with us. inspiring the nation's revival